In this video, I'll be working through the question you see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-1. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts as much as you need to. If you are looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 7, they tell us about a curve that has this equation here. And then they talk about a point moving along. Let me draw just a random curve. It really doesn't matter what it looks like. They're talking about a point moving along this curve. And they tell us that its y coordinate is decreasing 5 units every second. Now, what does that mean? What they want you to take from that sentence is, they want you to turn that English sentence into maths. And what that English sentence is, it says that y is changing. It says the delta of y, dy, y is changing. With respect to time, it says every second. That means with respect to time, time is changing. And it's telling you that change is equal to 5 decreasing, so minus 5. That's what they want you to take from that English sentence. Comes up most years, an English sentence, something like that, has to be turned into maths. Next, they ask you to find the rate at which the x coordinate is changing. Now the word there, rate, is important. Rate means with respect to time. So they want you to find dx dt. That's what they're looking for ultimately. How do you go about this? The main thing you need to notice here is, well, you have y. So you're able to find, let's do it down here, you're able to find dy dx. So that's what they really want, and you can combine both of these together to find it. Both of this and this one together to find this one. That's the trick to this question. So the first thing you're intended to do here is to find dy dx. There's y. Anytime I'm trying to find dy dx or differentiate, I like to change it so it looks standard. Instead of over x squared, I would change that to x to the power of minus 2. I also do that with square roots. Change the square root to the power of a half. Because differentiating this should be quite easy. The derivative of this is 2 multiplied by 4 is 8, and take 1 away from the x squared, which is x to the power 1. Here, minus 2 times 9 is minus 18, and take 1 away from that, we get minus 3. The derivative of minus 8 is 0. That's dy dx there. Now remember, what we're looking for is this one here. To do this, we're going to use the chain rule. I think the easiest way to think of the chain rule is just like this. Dx dt is the same as dx dt. If only we put something here. You can put anything here, because imagine this is dividing itself. This is like 8 divided by 8. It doesn't matter, it's only 1. In this case, so you can put anything here. So why not just put dy and dy? They'll cancel. This is clearly the same. But look, we know what dy dt is. It's right here. And dx dy, it's very similar to this. It's just that upside down. So this is actually equal this upside down, which is 1 over 8x minus 18 over x to the power of 3 multiplied by dy dt multiplied by minus 5. So we just put that up here, we will. Minus 5. You're pretty much finished. This is the rate of change of x. Is this at every moment of x? You tell me what x is, I'll tell you what the rate of change is. And they did tell us what x is. They told us x is equal to 2. So let's do it over here. Dx dt when x is equal to 2 is just all of this here. It's minus 5. Let me clear that off first. It's just minus 5 divided by 8 multiplied by, it is plus 2, isn't it? 8 multiplied by 2, which is 16, minus 18 divided by 2 cubed, that's 8. Use a calculator, we'll solve that for you quickly, or do it yourself by multiplying by 8. Every one by 8, top row becomes minus 40. 16 times 8 is, what is that? That's 80, and 3 8s are 24, so 6 eighths are 48. 80 plus 48 is 128. Yeah, minus 18. This is equal, 128 minus 18 is 110. Minus 40 over 110. 2 goes into both of them at least anyway. So minus 20, 55. Oh, sorry, 10 went into both of them. What am I thinking? This is equal to minus 4 over 11. And that's, let me just double check my answer. Yeah, that's the final answer to part A. Let me clear this off and we'll do part B. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they ask you to find the coordinates of the stationary points of the curve and determine their nature. Right, to do that, to find the stationary points, first of all, we just need to find dy dx, which we already have here, and put it equal to 0. So we're going to need dy dx. To determine its nature, well, there's a couple of, you could just start drawing pictures and make assumptions about certain things, but the easiest way to determine whether it's a maximum or a minimum or a point of inflection is just to find the second derivative. So it's in the wrong order, but let me put the second derivative here. That the second derivative is equal, just this differentiate. This becomes 8, 1 multiplied by 8. This becomes minus 3 times 18 is plus 54 times x to the minus 4. That's the second derivative. We can use both of those pieces of information to find these stationary coordinates. First of all, let's put this one equal to 0. So that's 8x minus 18 over x cubed is equal to 0. And we solve this. It's one equation with one unknown. We should be able to do it. First thing we do is multiply everyone by x cubed. Multiply this by x cubed, it disappears. Multiply this by x cubed, it becomes x to the power 4. And 0 by anything is 0. So we just solve this. We get x to the power 4 is equal 18 divided by 8, or that's the same as, let's see, 9 divided by 4. So we just need this to the power of 1 over 4. It doesn't go in fully evenly, but let me write it like this. X squared would be the square root of both these. Is plus or minus, this would be 3 and this would be 2. The plus or minus appears when we, not when we take the square root, but if something's squared, this is, x to the power 4 is x squared squared. So this plus or minus this squared would get this. So that's where the plus or minus comes in. We take square root again, as it were. Another plus or minus appears, I guess, but there's only so many plus or minus, so it's still just plus or minus. Plus or minus square root of all this, so 3 over 2. That's your two, so there's two answers, and they're both stationary points. They wanted the coordinates, so you need to find y. And y, let's put it up here. We have an equation with, this equation here with y. Let's put each of them in separately. First of all, let's do the plus one. Y is equal to 4 times this squared. Well, we had that just here. That's whether plus or minus squared, we get a plus. So we get 3 over 2. Plus 9 times divided by this squared, which again is the plus part of this, 3 over 2 minus 8. I said I was just doing the plus part, but the plus or minus has disappeared because they're both squared. They both got squared out. The plus and the minus part will be identical. I don't have to do the minus part. Hopefully that's clear. You can do it again if it's not clear. Say 4 divided by 2, this becomes 6. Turn this upside down and multiply it. 3 goes in 3 times, that's a 6. And that's minus 8. That's 12 minus 8, that's 4. If you want to do it again as a minus, you will still get 4. Minus this squared is still a plus, 3 over 2. You'll get identical. Plus 9. minus this squared is still 3 over 2. Nothing changes. You'll get y equals 4 again. So the two answers you get here are square root of 3 over 2 and 4. That's 1 point. And minus the square root of 3 over 2 and 4 is the other point. They're the 2 points you get from this. The only thing left to do is to determine their nature, meaning are they a maximum or a minimum? Because we know they're stationary points. So how do we do that? We simply put the x part into the second derivative. Well, the second derivative's has x, so we put the x into it. Luckily we have, let's write that as divided by x to the power 4. Remember, we do have x to the power 4 here. We know it's 9 over 4, so this should be quite easy to do. Let's do it over here. The second derivative is equal to 8 plus 54 over 9 over 4. And once again, this is the same whether it's a plus or a minus. A plus or a minus to the power of 4 is still a plus. If it's a plus, it's plus by plus by plus by plus, which is a plus. If it's a minus, it's minus by minus by minus by minus. 4 minuses make a plus. Either way, this is a plus. We don't even have to multiply this out, in fact. Well, let me continue on. This is 4 over 9. 9 goes into that 6 times. This is 8 plus 24, which is equal to 32. 32 is bigger than 0. But I knew already, hell, from this one here, I know it's bigger than 0. 8 is bigger than 0. 54 is bigger than 0. And x, anything to the power of 4 is bigger than 0. This all has to be bigger than 0, no matter what we put in here. So, if the second derivative is bigger than 0, that has to be a minimum. That has to be a minimum. And that's the answer to question 7. If you have any follow-up questions about anything there or in part A, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.